welcome to Unit 9 defg test review. Here we're going to start with multiplying and dividing. So when you're multiplying, the first step is to factor all numerators and denominators separately. So we're first going to look at 5n minus 40. We're going to factor that. Start off with the greatest common factor when you factor. So greatest common factor is 5. We're left with n minus 8. We divide 5n and 40 by 5. In the denominator, we already have an n minus 8, that binomial. There's no greatest common factor. There's no quadratic or cubic. There's no way, nothing we can factor there. Second fraction, the numerator 1. It's just a monomial. There's no way to break that down. And then we have 9n squared. That's also a monomial. There's no add or subtract in the middle between the 9 and the n. It's actually, they're already factors. 9 times n squared. That's the factors multiplied. So that's that. Next thing is we look towards, is there any factors in particular that are exactly the same? So binomials need to be exactly like binomials, like n minus 8. And the numerator simplifies with the n minus 8 in the denominator. Technically, it's n minus 8 divided by n minus 8. Minus 8 is 1. So we put 1s there. We look at whether they're like the 5 and the 9, those factors, if they can simplify, but 5/9 doesn't simplify. So in the end, we're left with, we just multiply across the numerator. So we have 5 times 1 times 1. So the numerator is just 5. In the denominator, we have 1 times 9 times n squared is just 9n squared. And it's simplified. On to number 10. So number 10, we're doing the exact same thing as multiplication. So we're looking at every numerator we factor, every denominator we factor. When we start factoring, we always look for greatest common factor. So in the first numerator, first fractions numerator, greatest common factor is 5n squared. We're going to divide each term by 5n squared, leaving us with n plus 5. The denominator is 9 times n. So our already factors 9 and n. Same thing with the next numerator. Then the last denominator, we have no greatest common factor. It's a quadratic. A is 1, so we can just do what two numbers multiply to c, which is negative 5, and add up to b, 4. And in this case, we have n plus 5 and n minus 1. And now that everything's factored, we just are looking to see what numerator and denominator can we simplify. So n plus 5 over n plus 5. Again, you can always put 1s for everything. And a 9n divided by 9n, 1 over 1, and that looks like to be it. So let's look at what we have. We clean it up. In the numerator, we have 5n squared times 1 times 1 is 5n squared over 1 times n minus 1 is just n minus 1. And that's our final answer. Alright, moving on. Now we have a division problem. Division problem, there's one more step to this than multiplication. I don't know how to solve a division problem, but I know how to change the division problem from division to multiplication. So we're going to keep the first fraction the way it is. Change that division to a multiplication, and you flip to the reciprocal. Denominator becomes the numerator, numerator becomes the denominator. And now it's a multiplication problem. Now we know from the last two problems, we just factor every numerator and denominator. This first fraction, nothing to factor. Second fraction, the numerator, again, there's no greatest common factor here. A is 1, so then we do what two numbers multiply to c that add up to b. That's b plus 4 and b minus 1. The denominator is just monomial. Just a constant term here, 6, so that's it. Now we're just looking, is there anything in numerator and denominator we can simplify? You can always put 1s when you simplify. And that's it. So we're looking at multiply across the numerator, we have p plus 4 over 1 times 6 is 6. That's your final answer. Let's move on. So E, this is, in your notes, E is really F. So, and on the test, it'll be F. The first one we're looking for this is adding and subtracting fractions. So the rule for adding and subtracting fractions, the first thing you need to think of is the like denominators. So here we have 1. It doesn't have a denominator, we just put it over 1. And we need like denominators, so what would be a denominator that both denominators can share, have the same? And that's z. So I'm going to rewrite this, y plus z over z plus z over z. And if we're looking, now we have like denominators, so the rule is keep the same denominator, and we just look for combining numerators. And if there's any like terms, you combine them. So we have y, that's one y here, plus z. So we have one z, right, and another z. You're adding, you're just counting. So that's together, you have two z's. And we look to see if we can simplify. Can we factor anything in the numerator? No, nothing to factor there. We look at numerator and denominator. Are there anything that can simplify? And there's not. You can't simplify the z's because 2z is a term, not a factor. We can only factor, or we can only simplify factors. So there's nothing here. That's your final answer. And that is A. Moving on. Don't really pay attention to this first part. That's just there as a stipulation. That was on the last problem, I skipped over it, but it really has no impact on the problem, on what you're doing here. It's just a stipulation that has to be said in order for you to do the problem. But there's nothing that you do with it. Alright, so this problem here, we already have like denominators, we're subtracting. So you have to always be careful with subtracting. We're subtracting this binomial, so we gotta distribute that subtraction in. I'm just going to combine it to one fraction right away because we have like denominators already. So I'm going to distribute it so it's subtracting a negative 2x, that's plus 2x, and a negative, or subtracting a negative 5, that's plus 5. It's kind of a weird way to say it, but yeah, when you distribute, this negative turns to plus when you distribute a subtraction. Alright, so we have this, and now let's gather like terms up on the numerator. 6x plus 2x, those are your like terms. You have 8x, and then the 7, the 5, that's 12. And in the denominator we have 2 times 2x plus 3. Now we look, whenever you combine numerators, you have to look to see, can you factor it? Well, we can actually factor this numerator. 4 is the greatest common factor. 2x plus 3 over 2 times 2x plus 3. This is nice when this happens when you simplify down more variables. Put 1 there if you like. 4 divided by 2 is 2, 1. And now we're just kind of cleaning up what we got. Numerator, we just have 2. Denominator we have 1, which is, ultimately it's just 2. 2 is your answer, so that's A also. Alright, number 14, gotta get like terms. On the classwork, or on the in class, I did this 2 ways. I'm only gonna do this one way here. Just take the second denominator, multiply by the first fraction. Take the first fraction denominator, multiply by the second. This is always the easiest way to do this. Sometimes it's easiest to factor the denominators to see what you have in both. If you want to ask more questions about that, you can practice a little bit in class, but it's just easiest to do this. I don't multiply in the denominator. Certainly can if you want. I know some of you do. We have to distribute this 2. So that's 12n plus 24. And the denominator, 3 times 6n plus 12. And then now we have like denominators, so let's combine those numerators. We have like terms. 6 plus 24. We have 12n from here, from the second fraction. Plus 12, or 6 plus 24 is 30. Over 3 times 6n plus 12. And we're looking at, now can we factor anything? Well, yeah, we certainly can. Numerator, we can take out the greatest common factor of 2. 6. Greatest common factor is 6, so we're left with 2n plus 5. over, and actually in the denominator here, you can see we can actually take out a greatest common factor there, so it's the greatest common factor of 6. We already have a 3 there, so this is 3 times 6, and that's n plus 2, when we factor out a 6 out of that denominator. We can rewrite it as 6 over 18, but we can also just see right now we can simplify those 6's. We're left with 2n plus 5 over 3 times n plus 2. Let's move on. Alright, so this was 9e. This is actually 9e in your notes. So we have, here we have they're called complex fractions. We have a fraction divided by another fraction. We have a fraction divided by another fraction. So this is doing division again. It's the same, very similar to what you did on D. You're just going to actually, you could rewrite it if you'd like. So it's horizontal division. Then you can see that you can keep, change, flip. So keep that first fraction the way it is. Well, you make it a division and make the denominator the numerator the denominator. And now let's see what we can simplify. Well, there's nothing to factor. We should go there first. Nothing, no numerator or denominator we can factor. We have 2 over 2 is reduces to 1 over 1. X over x squared, that reduces to 1 in the numerator and an x in the denominator. Leaving us with 1 times 1 in the numerator and x times 1 in the denominator, 1 over x. Alright, next one. This one we can do the exact same thing. I'm actually going to keep, change, flip right away. Write it like we did in the first step last time. We can just keep, change, flip the last fraction. And the next thing I would do is this t minus x is written backwards. Usually you write the biggest exponent to the smallest exponent. So we're going to write negative x plus 15. So we should rewrite everything else. I'm a fan of rewriting things because, well, it only takes you seconds, and that's less to have in your brain. That's on paper. Now you can see that anytime the leading coefficient or the leading number coefficient, leading term is negative, let's factor a negative 1 out. So I'm just going to rewrite that first fraction, and let's factor out a negative 1. We're left with x minus 15. So you have x minus 15 over x minus 15. Those factors will cancel. We have 3/9, reduces down to 1 over 3. And we have x to the 5th over x. X to the 4th. So looks like a mess, but what it comes out to, we have x to the 4th in the numerator over negative 3. You can move that negative 3 up to the numerator, or the negative, sorry, just the negative up to the numerator, and you get a. My next problem is a quick keep, change, flip. Keep that first fraction the way it is. Change it. And one thing you really got to be careful with these problems. I'm going to get this problem on a test. Select all solutions that apply. So at every step, stop and look. Is there an answer choice? This is talking about equivalent, not simplified. So there are every step is equivalent. So our first step here is right there at C. The next thing is to factor. There's nothing to factor. So our next step would be to simplify. So here we got to be really careful because everybody simplifies in a different order. So we have, if we simplify the a squareds, 25 over 5b, is that a possibility? Yes, it is. So that's my answer choice. And we look at simplifying 25 over 5, 5 over 1. So that would be 5 over b as an answer. That's A. So there we go. We got 3 answer choices. So actual simplified is 5 over b. That's the most simplified answer. They're all equivalent to the ones that I chose. Now, last problem on this, we have 9 over a squared plus 1/2. You need to do that separately. 9 over a squared. We need to combine those fractions. Plus 1/2 over. So let's combine those. Sorry, let's just combine those. So we need to get common denominators. You do a squared over a squared in the second fraction. First fraction 2 over 2. And so it becomes 2 times 9 is 18. Plus 1 times a squared is a squared. The denominator is 2a squared. I guess I just automatically put them together. I probably should have done that. But once you have like denominators, you can combine the numerators. That's good. So the second fraction, we have 3/4. The bottom two fractions that we have to add together, plus 4 over a. So now we have to get like denominators again. So it's 4 over 4. A over a. And so now we have like denominators, so I'm going to combine the numerators. We have 3a plus 16. It'll be 3a from here plus 16 divided by, and they're like denominators, so we'll just write them down for a. So now we have fraction divided by another fraction, so we can keep changing it. So keep that first fraction the way it is. 18 plus a squared over 2a squared. Change this division to a multiplication. Flip the bottom. That's 4a over 3a plus 16. And can you factor any numerator or denominator? You can go around about looking at it, but no, there's nothing to factor. Now we're just looking at is there something we can simplify. And if you look, we have 4 over 2, that's 2 over 1. A over a squared, a, and there's nothing else to simplify, so let's look at it across. I'll just do 2 times 18 plus a squared. I prefer to keep them out of this factor. I see the answer choice as a look in here, and the denominator is a times 3a plus 16. The answer choice is actually when it's restricted the 2 in and the a in. So that would be, let's see here. Moving on. Alright, so these problems here, we gotta get like denominators when you have equations. This is G. So we have to get like denominators. We have to know what factors we have in our denominators first. So if there are any denominators you can factor. We have x squared minus 25. That is a difference of squares. So that's, you factor it, it's x plus 5, x minus 5. Now we're looking at all the denominators. What's in common with them? What's not in common? You need all the denominators to be in common. So what you need to do is just figure out what the greatest common factor or least common factor is. We have x plus 5s and x minus 5s in all the denominators. But we need all the denominators to be x plus 5, x minus 5. That's the easiest way for us to do this. Multiply that first fraction by x plus 5 over x plus 5. And our second fraction here, we're going to multiply by x minus 5 over x minus 5. When we rewrite this, we have 1 times x plus 5 over x plus 5, x minus 5. Subtracting 1 times x minus 5 over x plus 5, x minus 5. And it equals our last, that's x squared plus 3x minus 18 over the x plus 5. Just believe me that I'm writing it. X minus 5. Not a whole lot of room here. Sorry, guys. Now the next step is to, we have like denominators, so you just drop them. You solve the numerator, so we distribute the 1 in, it doesn't do anything. So you have x plus 5, subtracting, and you got to distribute this negative, so it's subtracting x, subtracting negative 5, so that's actually adding 5. That's equaling x squared plus 3x minus 18. And we have now terms, get them all together, x minus x cancel out, 5 plus 5 is 10, and I see it's a quadratic. It's squared, it's a quadratic. So first thing that whenever you see that type of problem is you need to make it equal 0, so it can be a quadratic equation. So either put it in the formula or a factor. So subtract 10, and so we have 0 equals x squared plus 3x minus 28. We practice a lot of factoring. For this, you could absolutely, so you can either factor this or you can use the quadratic formula. If you use the quadratic formula, it'd be 1 is a, 3 is b, and negative 28 is c. I'm going to factor this because it's the fastest way to do it. I see that the a term is 1, so this is going to be a quick, easy factor. So to factor this, we do what two numbers multiplied at negative 28, it'll add up to 3. And I guess first I should have said, is there a greatest common factor? There's not. So what two numbers multiplied at negative 28, they'll add up to 3. And that's x plus 7 and x minus 4. One of the reasons why you factor is an instance like this where it's easy to solve. It's quicker to solve than a quadratic formula. So we're going to set each factor equal to 0, plus equals 0, and solve for them. So we have, you subtract 7, you get negative 7. You add 4, you get positive 4. Those are both your solutions. Next problem. Next problem, we're going to start off the exact same way. We need to factor. See what factors we have in common, if there are anything, if there is anything in common in the denominators. So the first denominator we can factor out an a. You're left with a minus 2. The last denominator is the exact same, so it's a times a minus 2. And now we look, what's in common with all the denominators? Is there anything? And it's a is in common with all the denominators. What's not in common, and it's only in common with 2 of them, is a minus 2 and a minus 2. The middle fraction doesn't have an a minus 2, so we need to multiply by a minus 2. So then it'll be in common with all the others. Now they have all the same denominator. So let's rewrite this quick. That's 4 over a times a minus 2 equals 1 times a minus 2 over a times a minus 2 subtracting a times a minus 2. So what is this? 1. So looking at this now, we have all like denominators, so let's just drop the denominators and solve the numerator. So 1 we can distribute it in. The subtraction gets distributed, but it's only a monomial it gets distributed to. And now there's no quadratic here, it's just a left by itself, so it should be a pretty easy problem to solve. So let's just get 4 equals, let's combine our like terms. That's negative 3, a minus 3, and 3. You get a equals 7. Alright, on to the last problem. Factor, factor, factor. So x squared minus 4, that's the difference of squares. And look what's in common with the denominators. Oh, looks like we both have x minus 2's. But the second fraction doesn't have an x plus 2. Let's put it in there. Let's multiply by x plus 2 over x plus 2. A lot of times I'll put binomials in parentheses just to remind myself that they are binomials, and when I go to multiply, I need to distribute. So, alright, let's do this. We have all like denominators, so let's drop the denominators. And let's look at the numerators. So that's what we're left with. When you're distributing binomial times binomial, you need to multiply every term times every term. So x times x, x times 2, 4 times x, and 4 times 2. Now let's look at I see a quadratic, so if it's a quadratic, we gotta think quadratic formula, and just set that up. Or you're thinking factoring, you have to get all the terms to one side. Have the equation equals 0. So x squared 2x plus 4x is 6x. And 8 minus 8, those get canceled. So now we have, you can do this with the quadratic formula again. I think this is going to be an easier one to factor. If you use the quadratic formula, a is 1, b is 6, and c is 0. So you absolutely can use the quadratic formula. A equals 1, b equals 6, and c equals 0. There's no constant term, so that's why c is 0. But I'm going to factor. We worked really hard on factoring, so let's do it. Greatest common factor here is x, and what's left is x plus 6. And the idea behind factoring and solving using factoring is to set each factor equal to 0. So like x is a factor, so x set that equal to 0. Well, it's already solved. X equals 0. That's one of my solutions. And then the other factor is x plus 6. Let's set that equal to 0 and solve for it. And you get, so also negative 6 is a solution. Ultimately, you should check these for extraneous solutions or solutions that you mathematically can get. But when you go back and check, you should substitute 0 into the original problem. For the x's, all the x's, see if left side equals right side. And you should also do negative 6. You should substitute in for x for left and right side. Just for timing purposes. Don't really worry about it for this case. Right?